And welcome back to the morning show. Coming up on 6:50. That means Wise Guy Wednesday time. And Matt Sellin, our U of I physics professor, is here. And we're talking about boiling and freezing points today.
Yeah, and it's a good excuse to make some ice cream because it's nice and warm outside. That's really where this is going. But anyways, yeah, so it turns out that on the Celsius scale, water freezes at 0 and it boils at 100. That's kind of the definition of the Celsius scale. And room temperature is about 20 and body temperature is, I don't know, 35 or something. And but you can change that for water by mixing the water with some impurities.
Okay.
And salt is a very common one, but salt's not the only thing that works, as I'll show you. And so what I have here, just to illustrate this, is I have some boiling water, and the one that's in the little beaker is just water. And if I'm putting this thermometer in it, and you can read it on the digital scale. It says 99.1 or 9, but that's really means 100. This thing is not a perfect thermometer. In the next one, there's this water that I dumped a whole bunch of salt into. And when you see the boiling point of that, it's 108, 109 degrees. It's been elevated quite significantly.
Sure.
And you can do the same thing with the freezing point. So this is called boiling point elevation. And the way this works, it's nothing really chemical about it. It just, if you have a bunch of, for water to boil, the water atoms have to get together and they have to form a little gas bubble, and the gas bubble has to escape. If you have a bunch of impurities like salt ions floating around inside the water or dissolved in the water, it's just harder for a little pocket of pure water to form to make a little bubble. It's just, this makes it more difficult, and so that raises the boiling point. It has to do with entropy and thermodynamics.
Does water boil faster? Or does it? Because I know every time I make macaroni and cheese, my wife said, put some salt in there, get the water boiling faster.
No, it doesn't make it boil faster. It doesn't make it change the temperature, because I put a lot of salt in here.
Okay.
And you know, when you put a pinch of salt, all it does is make it taste a little better, because we like to taste the salt.
Okay, but, so I can tell her she was wrong?
Yeah.
And I can say you
can back it up as far as you know. I'll back you up.
Matt said you're wrong.
And so the same thing happens with freezing. So here I just put ice in these little cups.
Okay.
And I put a little water in with this ice, and you can hear, I'll put this behind it, you can see that the freezing point is darn close to 0. It's 0.2 degrees. In this one, I put salt in with my ice. So I'm going to jam the thing in here. And notice that this now says minus 15 degrees. That's a lot colder than 0.
Sure.
And with these ice cubes, I put alcohol. And if you've ever, parents that is, mixed a martini and you've shaken it, you realize that the mixture gets very, very cold.
It does.
And what happens here is that the alcohol serves the same purpose as the salt does, and it lowers the freezing point of the water to minus 15 degrees or minus 16 degrees in this case. Okay? And it's for the same reason. It's harder for the molecules to get together to freeze when there's an impurity that kind of gets in the way. And that's really all that's going on with that. And the reason this gets colder, and you might kind of wonder, okay, when you put ice cubes in a glass of water, like this is just pure water, when I put the water in here, the water was kind of warm.
Right.
I dump the ice in there, and it cools off. Now, why is that?
Because the ice is frozen.
Because the ice is cold, but that's not really. It's not that the ice is cold that cools the water down so much. It's because the ice melts. And melting ice requires heat, and that heat is drawn from the water, and that cools off the water. So if you have a solution where it can go even colder than 0 degrees, then the ice just draws more heat out of the solution, and it gets even colder. So the thing, even though the whole thing may start at 0 degrees, when you put salt in there, it goes down below where it was.
I see.
Okay,
it's called. Take a big swig of this one.
No, you don't want to.
They're marked.
That's right. And what we're going to do is we're going to put a bunch of ice in a big old baggie.
Okay.
Pour some salt in there.
All right.
We're going to mix cream and vanilla and sugar in a little baggie.
Okay.
We're going to put those together and shake, and we're going to make some ice cream, and we'll do that when we get back.
We'll do that in 30 minutes. All right. Matt Sellin, our Wise Guy, thank you very much. And if you have any questions for Matt, or you want to check this out again, just go to the morning show at wcia.com or go to Matt's website, wiseguy.net. 6:53. Let's check in with Jennifer Ketchmark.